Okay. Edward Hubble is known for helping to kind of show this or prove this, that he showed that velocity, which is speed and direction of an object in a galaxy, increases with its distance from the Earth. He implied that the universe is expanding, and then this concept is what we know as Hubble's law. So he was able to show us that the galaxy is expanding, it's getting bigger, it's increasing its distance from Earth. So it's showing that the universe is growing, expanding away. Okay. Before we get to that, I'm going to show you guys a little clip. Sometimes it helps to hear a little bit more.
Rather beautiful, isn't it? It's quite literally.
Uh-oh.
You need new glasses.
Sorry,
so
guys.
Why not have them delivered to your doorstep?
It doesn't like it when I...
At GlassesUSA.com.
We're going to have to sit through this little ad here for a second. Sorry. When is it loading? There we go. Okay. You guys can't hear the sound. There it is.
Everything.
Oh,
From the
my
very
goodness. Sorry about the technical difficulties today. Whew.
Rather beautiful, isn't it? It's quite literally got everything, from the very big to the very small. Sure, there are some less than savory elements in there, but on the whole, scholars agree that its existence is probably a good thing. Such a good thing that an entire field of scientific endeavor is devoted to its study. This is known as cosmology. Cosmologists look at what's out there in space and piece together the tale of how our universe evolved, what it's doing now, what it's going to be doing, and how it all began in the first place. It was Edwin Hubble who first noted that our universe is expanding by noting that galaxies seem to be flying further and further apart. This implied that everything should have started with the monumental explosion of an infinitely hot, infinitely small point. This idea was jokingly referred to at the time as the Big Bang, but as the evidence piled up, the notion and the name actually stuck. We know that after the Big Bang, the universe cooled down to form the stars and galaxies that we see today. Cosmologists have plenty of ideas about how this happened, but we can also probe the origins of the universe by recreating the hot, dense conditions that existed at the beginning of time in the laboratory. This is done by particle physicists. Over the past century, particle physicists have been studying matter and forces at higher and higher energies. Firstly with cosmic rays, and then with particle accelerators, machines that smash together subatomic particles at great energies. The greater the energy of the accelerator, the further back in time they can effectively peak. Today, things are largely made up of atoms, but hundreds of seconds after the Big Bang, it was too hot for electrons to join atomic nuclei to make atoms. Instead, the universe consisted of a swirling sea of subatomic matter. A few seconds after the Big Bang, it was hotter still, hot enough to overpower the forces that usually hold protons and neutrons together in atomic nuclei. Further back, microseconds after the Big Bang, and the protons and neutrons were only just beginning to form from quarks, one of the fundamental building blocks of the standard model of particle physics. Further back still, and the energy was too great even for the quarks to stick together. Physicists hope that by going to even greater energies, they can see back to a time when all the forces were one and the same, which would make understanding the origins of the universe a lot easier. To do that, they'll not only need to build bigger colliders, but also work hard to combine our knowledge of the very, very big with the very, very small, and share these fascinating insights with each other and with, well, you. And that's how it should be, because after all, when it comes to our universe, we're all in this one together.
Okay. So a little clip there to kind of piece it all in together. So Thinking about how do you think these early scientists, say like Hubble and Einstein, how do you think they figured this out, or how did they come up with those ideas? Like, we know technology has to be used. What kind of technology do you think that they had available to them? Is there anything you can think of, like when you look up into the sky, how are they seeing these galaxies? Or you guys ever used a telescope before?
No, I haven't.
Never. Okay, but you know what one is, right?
Yes.
Okay, yeah. So we think about early technology. Telescopes were kind of like this amazing development that came along with helping scientists understand what was going on in our galaxy and how the Earth came to be. And like they talked about in the video, now we have scientists, particle physicists. So if you go in and you continue studying science, you go into physics, you'll learn more about these particles, these subatomic particles that they were talking about. And scientists now can use, as technology has increased, they can kind of experiment with this in a laboratory. Okay, so we know through the Big Bang Theory is that our universe is expanding. And that's when we get into discuss this whole idea about the electromagnetic spectrum and the red shift and the blue shift, which helps go along to help kind of prove that the Big Bang Theory, or helps give evidence for the Big Bang Theory, we'll say that. Okay, so the electromagnetic spectrum, so that goes into the next little step here. And this is a range of radiation that is given off. And this is energy that travels and it spreads out as it goes. And there's lots of different types of energy on the electromagnetic spectrum. I'll show you that here in just a second. But the most probably common one that we know of is light, visible light, like the light that we see. Like right now when we're looking at our computer screens, we're seeing this visible light. So visible light, it comes from a lamp in your house, or the radio waves, which is another one that you might get from listening to the radio. There's other types of electromagnetic radiation that makes up this whole entire spectrum. So the spectrum is the name that we give for all of these types of radiation. And let me give you, let's take a look at a picture of that. There, actually, let's go up to this one. So when we think of the electromagnetic spectrum, you might have seen something like this. It shows the energy, and energy moves in waves. Okay, so we got sound waves. You can think of the waves in the ocean. Those are all different types of waves. And again, waves are what carry the energy. So we can see here, it shows what we call the wavelength. So you'll notice here at this end, the waves are very close together. And then as you move away, they spread apart. And when the waves are closer together, we have an increase in energy. That means it's a high wavelength, so you're gonna have more energy. As they slow or move slower, we see less of them, our wavelength and our wave energy is then decreasing, okay? So on the spectrum, we have all different types of radio waves. And the reason why they're on one end or on the other end or right in the middle has to do with the amount of energy that they have. Okay, so high energy is right here. And these are gonna be things like, think of gamma rays, probably you've had an X-ray done maybe before, ultraviolet rays from the sun. Okay, so these are a much more higher frequency, more energy, higher wavelength. And then on the other side, we have less energy, which is going to be like your radio waves. And kind of right in the middle is that visible light. Now, visible light's pretty important because this is the only type of radio waves or the light that we can see, okay? So here is another little kind of image that kind of shows you all the different types of rays that we have. And again, we have high energy. So again, we talked about those gamma rays and the X-rays. UV light from the sun. Here's our visible. This is the only light that our eyes can detect. And then we go to less energy, which is going to be, up to the radios. Let me go back there. Okay. So when you think of light, you probably think of what your eyes can see. The electromagnetic spectrum is a term that we use, that scientists use to describe the entire range that light can exist, from radio waves to gamma rays. Okay. This shows you the colors. You might have heard of that mnemonic saying. It's kind of Roy G. Biv. Mnemonic sayings are used to help us remember something. So we think of the colors of the rainbow: red, orange, yellow, green, blue, and violet. And that has to do with the frequency and the amount of energy that gives us these different colors. Let's move a little bit forward here. Okay. So again, visible light is the light that humans can see. These colors make up what we call the visible spectrum. And again, it talks about that rainbow. So we can see red, orange, yellow, green, blue, indigo, and violet. Okay. So we can see, even with the colors have different amounts of energy. So we have red is going to be, you can see the wavelength here is less. So that's less energy. The wavelength over here, it's very, very close together. It's going to be more energy, a higher frequency, and that's going to be your violet colors. Okay. Okay, so great. We learned about how energy moves through waves, and visible light is what we can see. Well, what does this mean to help us understand the Big Bang Theory? Okay, and this comes from here in the lesson, this red shift and blue shift. It says scientists can figure out how far away an object is by measuring the light energy that it produces or it gives off. So you think about it, consider an object in space. It can be a source of light, such as a star. Now imagine a scientist is looking at that star through a telescope. If that star moves toward the scientist, the light waves bouncing off of it get bunched up like a traffic jam, that higher frequency. When the light waves bunch up, they become shorter because they get pushed together. And this is how scientists know that a star is moving towards them. On the other hand, if the star is moving away from the scientist, the light waves spread out. As they spread out, they get longer because there is more room for them to go. So this is where we get the terms red shift and blue shift. So we think of blue shift, the light waves get shorter and they bunch up, and then the light source is coming towards us. In the red shift, the light waves get longer when the light source is moving away from us. So let me give you take a little bit, another example here. Okay, so we can see here with the blue shift, we can see that the light waves, energy, that gets bunched up, higher frequency. When we have red shift, they're more stretched out. You guys doing okay so far? I know it's a hard topic because it's so abstract, and we're talking about these light waves that we have to have, tools and technology to use. And then we're also talking about, the galaxies, millions of miles away from each other. Okay, so again, here you can see this little example showing the Earth. As the waves are moving towards, they get bunched up. As they move away, they spread out more. Okay. Now, I wanted to show another little clip here.
Hoping to talk about redshift and the Doppler effect, and how this relates to models of the universe expanding and the theory that the universe began with the Big Bang 14 billion years ago. But first, the Doppler effect, or Doppler shift. This was first named after the Austrian physicist Christian Doppler, who proposed it in 1842. And what this states is that there is a change in frequency of a wave for an observer when there is movement relative to the source of the wave. And it can commonly be seen when a vehicle producing a siren or horn approaches, passes, and moves away from an observer. For example, if you were standing on a street and an ambulance approached and passed you, first of all, as the ambulance approached you, the sound waves produced in front of the siren would be compressed together as the ambulance moves towards you. This compression of the sound waves gives a higher frequency or high-pitched sound. As the ambulance moves past you, you would hear the sound exactly as it's produced. As the ambulance moves away from you, the sound waves from behind the ambulance are stretched out, giving a low-frequency sound or low pitch. The same thing can be seen with light waves, and particularly light waves produced by stars. For an observer, if a star was moving towards them, the light waves produced by the star in front of the star would be compressed together, giving high-frequency light waves. High-frequency visible light is of a blue colour, so we call this blue shift. If a star is moving away from an observer, the light waves produced behind the star will be stretched out, and this will give low-frequency light waves, and low-frequency visible light is of a red colour. This can be seen with stars when we look out in the universe, that the stars have a red tinge or red shift, as we call it, showing that all the stars are moving away from us. This indicates that the space between stars is getting bigger, and therefore the universe is getting bigger. The further away the stars are, the bigger we see this red shift, so the universe must be continuing to expand. Physicists have theorized that if the universe is getting bigger now, then we rewind, we could take the universe back as it shrinks and shrinks to 14 billion years ago, when the universe must have been very, very small. And by using this, they've come up with the theory of the Big Bang, being the beginning of the universe. I hope this podcast has helped a bit to explain redshift and the Doppler effect and how they're used as a...
Okay. Oh. So hopefully that little video clip helps put that in perspective too. So they use the example of like an ambulance when you hear a siren, and it's like that sound as it's getting closer and closer, it's like it's getting faster and faster, and it's getting louder and louder, and that's more and more energy. So those waves are getting scrunched in together, okay? And then once it passes you by again, it's moving away from you, and the sound decreases. There's less energy, and it starts to like stretch as you hear that siren. The siren sound stretches out. So it's like longer and longer and longer, and then softer and softer and softer. So good so far? Anybody have any questions?
No.
Okay, so you can verbally say it, just shout it out, or you can chime in on the chat message if there's something that's sort of like, wait a minute. Okay, so I just want to show this picture. I think is pretty cool to see. This is an image that shows a galaxy out in space. And what we're seeing is what it would look like seen in like radio waves. And as we can see the different colors, you know, we can see the rainbow in here. And so that's telling us the amount of energy that we can see. So the different color maps, the velocities. So the red gas is moving away from us, and that blue is moving towards us. Okay. So again, the redshift, it's caused by an expansion in space. So as a result, we're trying to tie this into, well, how does this help us with the Big Bang Theory? As a result, the Big Bang, that tremendous explosion, expansion, you'll hear people use those two words when they talk about the Big Bang. Expansion, explosion, pretty much it means the same thing. It's the start of what we know of now as our universe, okay? The universe is expanding, and most of the galaxies within it are moving away. So it's pretty cool to think, you know, space is getting bigger and bigger. It's expanding. Our galaxy is expanding. Okay. Okay. Any questions about redshift, blue shift? Questions about the Big Bang Theory?
No.
Thank you. Okay. Okay. Well, then I want to open it up to allow you guys to have a chance. If you have questions about science or a lesson, an assignment, concept, I can definitely help you out here. And again, I might not be your specific science teacher, but I can still help you answer these questions or get the help that you might need during these live sessions as well. And during each live session, we'll have two opportunities. Usually it's kind of set up, the agenda set up that I'll go over a topic, and then I'll have a question and answer period, and then I'll go over another skill, and then we'll come back to ending with your guys' questions that you might have as well. So if you don't have it out now, you can think about it for just a moment, and I'll come back and open it up for questions again. Sweet. Okay, so let's move on to our skill. Our skill for the week. We're going to look at compare and contrast. And we know that we use compare and contrast in other topics, not just in science, but I'm going to use some science here today to help us. So compare and contrast. What is it? Why would we use it? Anybody want to give their thoughts or help us answer that question? Compare and contrast. Why do we use it? What is it? We'll start off with each one then, okay? We'll break this down in half, compare and contrast. So if we think of the word compare, can somebody share your thoughts on what compare means? When you're comparing two items, what are you doing? Okay. Comparing, we are looking at, I'll type it in, differences, right? We're comparing two items. If we're comparing a cat and a dog, we're looking at the difference between them, okay? How about the opposite of that? Contrast. If comparing is looking at differences, what would contrasting be? Sorry, my typing is a little different there. So compare, we're looking at differences. Contrasting, we're looking at things they have in common or that are similar, looking at similarities. Okay, so comparing and contrasting, we are looking at differences and we're looking at similarities between, you could be looking at two items or you could be looking at a bigger grouping of items as well. So why would we use this? Why would this be important to look at similarities and differences? I'm sure it kind of depends on what the topic is and what our items are that we're comparing and contrasting. We use it to help show relationships. We look to see what they have in common and then what they have that makes them different. So it's kind of looking at it as a big picture and then kind of breaking it down so we can get a better understanding of maybe how these fit together or what they mean. Okay. Two ways that we can do this is two great tools. You've probably seen these. Shake your head yes if you have. Venn diagrams and T-charts. Yes, these are so helpful. These are called what we call graphic organizers. And graphic organizers are a great way to organize our information in a more easier to understand visual type, okay? So in a Venn diagram, we have, in this one they use circles, and you probably may have seen one that has like 3 circles. You know, we've got 2 different items in this one, so we have 2 circles. And we have a space here that shows what is different, and then we have a space right here in the middle that is contrasting that, showing those similarities. So we have our compare, and then our contrast. What is different, and then what is the same. This is a great one because you can visually, like you can just look at it and you can say, okay, here's their similarities. This would be what they each have, and then this is what they have in common with each other. Okay. Same thing with a T-chart. You got 2 different sides here, so you can show their differences, and then you could, like down at the bottom, you could show what they might have in common. Okay, so a little example here to show you how this might work. And this could be something that you use like in your notebook for taking your notes. It's an easy way, you can just write this out. So we've got a Venn diagram here showing comparing and contrasting animals and plants. Can you guys help me out with this one? Let's start with, what's different about an animal?
They have 4 legs.
Okay, they could have 4 legs. So a lot of animals have 4 legs, or we could say they have more mobility. So
Yeah.
move, you think about. No, that might be spelled move. This little program doesn't have a spell check, sorry. Makes it a little bit harder for me. Animals, they have a different kind of means of reproduction.
Yeah.
I'm gonna say reproduction here. So how they produce offspring. And maybe if you're taking biology or you've had biology, you would also know that they have different types of cells. We have animal cells and plant cells. So they have animal cells. I'm just going to do a couple here just to give you an idea. Okay, what are plants? What's unique about a plant that an animal would not have or doesn't have? We'll go on the other side of this one that we just talked about, cells. Plants have what we call plant cells. And pretty much what the difference is with that is, if you were in the session last week, we talked about photosynthesis, and we talked about how plant cells have these structures called chloroplasts that allow them to use the sun's energy to produce food or sugar for the organism and also for us. So the difference between plant and animal cells is really the kind of structures that they have in them. Okay. How do plants move, or do they move?
No.
No. Okay, so we can say less mobility. It's funny because there is, in the course, it does talk a little bit about, in the biology course, it does talk about, characteristics of life, and it talks about, well, one of the characteristics of life is that the organism needs to be able to move. And when you think about that, you're like, but plants don't move. But they do, they grow. If you think about that, that's moving. They also have different types of, you can see, like, I guess I'll say the word strategies would work. You think about, if you've ever seen a plant, some plants, they turn to face the sun, or they open up when it is sunny, or they open up when it is dark. And so that is the type of moving. So they might be moving to change their surroundings, get the items, the requirements that they need. So, but they do have less mobility, because yes, you don't see plants just up and running around on their roots, right? Okay. If you think about the structures of a plant, they could be different, like roots and stems. We'll just say different structures here for now. And also their reproduction is different. Okay, what do they have in common?
They need food.
They sure do. Good one, thank you. So so this is our contrasting part, the similarities that they share. They need energy. So energy is what we call.
They both need water.
Water, you got it. Another one, all organisms are made of, so an organism, we could also say what they have in common is that they are organisms. We'll add that one in there too. And to be an organism, you are made of
Cells.
cells. Oh, I'll be even more specific and say cell parentheses. Did I get that? Cells. Because we do have some organisms that are just made up of one cell. Okay, so here we can look at 2 topics, animals and plants, and we can say, hey, this is what we know is different about animals, but here's what they share in common. So it gives us a visual idea when we think about animals and plants. You can see what is different about them. And then we can also look at it, kind of pull it all together and show what is similar. Okay, so going back to the red shift and the blue shift that we just talked about earlier here in the lesson. What do you guys want to start with? Should we say what they have in common? Sometimes it's easier to go straight in the middle. What do they have in common? Contrasting them. What do they share that's similar?
Colors.
Okay, they're made up of colors, or they show a color.
Another thing that they're same of is they both have wavelengths.
You got it. Yes, that's a great one. So waves, they're both waves. They both have wavelengths, which is going to help us in that contrasting part. It's not going to go there. Okay. And what do you guys remember this? What do all waves, what do they carry?
Sound.
They can carry sound. And sound is a type of, all waves carry
Energy.
energy. Thank you. There you go. I was spelling it out for you, giving you a little clue. Yeah, so energy. So some things they have in common. They're made up of colors. Waves, they have a set wavelength. And that wavelength is then carrying energy. So pretty much what the big thing about them is that they're waves, which is carrying a type of energy. Okay. What's the difference? Should we start with the red? Let's see if I can pull up this picture. So we can see here, there's our red.
The red goes away from you.
Got it. Yeah. So what is different? Red is moving away. Oops, that's not cool. Okay, if red is moving away, what's blue doing then? Oh, click the wrong one.
Coming towards you.
Thank you. Yeah. Okay. Another difference between them, the big thing, is if you look at their wavelengths, what do you notice? Here's blue, the blue shift.
The blue shift is more crunched together than the red shift.
That's right, yeah. So their wavelength is more, so it has a higher wavelength, whereas redshift has less wavelength because, again, it's expanding, it's moving away from us. So we say higher, you can say frequency. Or higher wavelength. Okay, and then for the red, lower frequency, because again, it's stretched out, that wavelength is less. Okay. We can also talk about, we know that they are colors, so they have in common that it's a color, but we can say that red shift is red color, and that's because it has less energy. Blue shift is blue color because it has more energy. It'll compare and contrast. Okay. So again, compare and contrast is great. These are two, I showed you two different graphic organizers that you can use, a Venn diagram or a T-chart. I like to use a Venn diagram because I like to see these, I think the visual of the circle showing you like, this is what only redshift has, and this is what they share in common. I think that helps me as a learner see the differences and the similarities between the two topics. Okay. So probably a skill that you use in your other classes as well, but it will come in handy in science, as there is a question that talks about this in the lesson, redshift and blue shift as well. Okay. Okay. So again, I want to open it up now as another opportunity that you have. If there is a question on an assignment that you are stuck on or you want more information, something is not clear, I'm here right now to help answer your questions, help you with your topics. And again, like I said earlier, even if I'm not your particular science teacher, I'm still here to answer questions that you might have about science. If you have the courses or the assignments, or if you're having any other issues, I might be able to help you out.
I have a question. I'm having an issue. Okay. It's Kanisha Mason. And the one I'm having an issue with is what do I say? The ocean food chain. I cannot get that for whatever reason.
The food chain one?
Yes, like it. I don't know what I'm missing or what I'm not reading or putting down correctly, but it's slightly confusing me.
Okay, is
like
it
the whole course?
when you're doing the assignment, when you're actually making the food chain?
Yes. It's saying I'm doing it. I was like, you've been told I've been doing it wrong, and I'm like confused on how am I doing it wrong.
Okay, in that assignment, there is a really great.
Let's see.
Let's see, and that is in. Oh. Tanisha, is that in the biology? Or is it
Earth Science Semester 1?
semester? Okay.
It's like in the last week of week 4. Activity 721, ocean food chains.
So let's pull that up here. Okay, is it this one in this activity you will create an example of a food chain?
Yes.
Yes. Okay. is it? I'm looking for. Does yours show the rubric?
Let me go back to it and see.
Okay, so yours just looks at this.
Yes.
Look just like this one. Okay. So in this activity, you'll create an example of a food chain that might be found in various parts of the ocean. Okay, a half-page summary of your findings. Remember that a food chain is a series of organisms linked in a chain that absorbs energy through one another. So you have your producer, right? Because we have to have, in a food chain, we have to have an energy source. So we need to have organisms that can use the sun's light to produce food. Okay, and then we go into our consumers. Okay, so your food chain should begin with a producer, and it should end with what we call an apex predator, which is the top predator in that food chain. Make sure to label the name of the organism you choose and its role that it plays in the food chain. So investigate, provide an example of a food chain in one of the following types of locations. So you have a choice. You can do estuary, intertidal zone, open ocean, or a deep ocean. And what you can do is you have the option, you can go back into the lesson where it talks about the different types of organisms that you're going to find in a food chain. So again, it talks about this whole producer, and right in here it talks about phytoplankton. So here's our primary producer in ocean environment. So phytoplankton are the basis for all food chains in the ocean. Okay, so this would be your first example. Would be the producer. The beginning of your food chain is going to be that phytoplankton. You got that one?
Okay, yeah. Because the only problem was I was kind of confused on it because I'm like, okay.
There's different types, and then it goes into the next section. It talks about there's different types of phytoplanktons, but probably the most common one that we know in sea life is algae. I think that's
right.
So that's a good example of a.
Okay, so it wants me to take like algae and like try to go through the whole thing from like how it started to how it is now.
No, it's asking you. So then we know that the sun, we get algae is a producer, and so it uses the sun's energy. So that's the basis. That's the bottom of our food chain. And then what would eat algae?
You said, will we eat algae?
Yeah. So
what I mean.
So here you have your producer, and so then you would have your next, what we call like our primary consumers. Organisms might eat, maybe it's a crab.
Right.
And then as you move up, what eats a crab?
Oh, okay. So it just wants me to explain the actual food chain.
It wants you to give an example of a food chain. Yep, starting with the producer, and then moving up to what we call the top apex predator, or the top of the food chain, which, probably in an ocean. I want to say that they thought there was an example. Yeah. So here.
Okay. So like the shark could be the example. Okay.
That's right. Top of the food chain. So the shark would be that apex predator. Yep. So in that assignment, they're just asking you to give an example of a food chain, starting with the producer, moving up to the primary consumer up to the apex predator. Yep.
Oh, okay. Okay, that's how I was getting around. I was just more or less explaining the example and not the actual food chain.
Yep. Okay. No, you're not explaining how the food's created or made. We did that earlier with photosynthesis.
There you go. Yeah, that's the one I was confusing it with. Okay. So I have to do an actual example of a food chain. Gotcha. That was one of the biggest things. Actually, it's also one in my second semester. Which one is it?
But second semester?
Yeah, so I'm in the second semester now. And which one was that? Oh no, no, no. I got it right. Okay, nope, we're good then.
No questions? You got it?
Yeah, I got it.
Okay. Well, again, with these live sessions, they are great because, you know, like we just saw here, if you have a question, you can get that question answered right here, right now. Okay. Also, if you have topics that maybe you would like to see one of your teachers do a live session on, I would love to have your input on what you think would be a good topic, either being a concept, a topic that you have in your course, like today we're talking about redshift and blue shift. You know, if you want more information about food chains, I would love to create a lesson around something that's going to be beneficial where you're at. So if you have ideas, you can send me a chat or you can email me. Same thing with a skill. If there's something that you're stuck on, I can help you. I would love to do a demonstration or give a little live session on that too. So I love the feedback so that I can help plan and make this as successful and meaningful and useful to you guys as possible, okay? Okay, guys. Well, then we will go ahead and wrap this up for today. I know that there are lots more live sessions with lots more teachers and different topics and content areas, courses that are coming up. So I think that is going to be great for you guys. Okay, I'll be back on again next week. I'll send out a message to let you guys know, but it should be, I think it is. Yes, it is. It is next Thursday, same time. As well. So again, if you have any ideas, I can send me your ideas, and I would love to go over that, or bring your questions to the next sessions, and we will see you then. Okay, you guys good?
Yeah, thank you.
Thank you. Okay, have a great day, you guys.
You too.